we're going to create Hungry Dragon. Okay? Inside of this test tube, right, is potassium chlorate, KClO3. All right, if you look on the label, which I've drawn, because I have a big, huge container, and so I took that big, huge container and condensed it down to a smaller container. Health is 1, flammability is 0, reactivity is 3. This is a scale of 0 to 3.
Oh.
Okay? So this is highly reactive. Its exposure is fairly minimal.
Wow.
So this stuff, potassium chlorate, right, is KClO3. Okay? The chlorine in potassium chlorate is in the +5 oxidation state. Okay, chlorine is right below fluorine on the periodic table, right? So chlorine really doesn't want to give away its electrons. But oxygen kind of, well, gets what it wants, right? And just takes the electrons from chlorine. And so chlorine's very unhappy about it. Much rather be the -1 chlorine, right, that stole an electron for itself and then bonds with potassium. So it's got the potassium already, right? It just needs to get those electrons back. So it kind of just reacts with oxygen within potassium chlorate. And you have what is called a redox reaction, where it's a reduction oxidation where the electrons are transferred. Okay? And you produce oxygen gas. So in this reaction, you see there's bubbles in there. And that's oxygen gas being formed. Okay? And there's so much energy released in this reaction of the forming of the new bonds, because you're forming an ionic bond with potassium chloride, that it's enough to ignite the splints. Okay? But I like to think of it as our fairy tale dragon is now hungry, and I want to feed him, and he says thank you by spitting fire at me. Okay, so here we go. Ready? What? So he said thank you. See if he'll say thank you again. The problem is he's a dragon, and so he gets very, angry very easily. Or by saying thank you with fire. Usually. And sometimes it's too good and he throws up. Like that. Right. Don't throw up. Kind of awesome. So, what you see here on the side of the test tube, right, is that white stuff. What's that white crystal? Potassium chloride, right? It's the salt that potassium chloride, right, what chlorine wanted to be. And then